I am Dr. M. Tamil Selvi, Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. The title is Fibre Reinforced Concrete. Fibre reinforced concrete is a plain concrete possesses a very low tensile strength, limited ductility and little resistance to cracking. Internal microcracks are inherently present in the concrete and its poor tensile strength is due to the propagation of such microcracks, eventually leading to brittle fracture of the concrete. In the past, attempts have been made to improvement in tensile properties of concrete members by way of using conventional reinforced steel bars and also by applying restraining techniques. So when loaded, the microcracks propagate and open up, and owing to the effect of stress concentration, additional cracks form in places of minor crack. The structural cracks proceed slowly or by tiny jumps because they are retarded by various obstacles changes of direction in bypassing the more resistant grains in matrix. The development of such microcracks is the main cause of inelastic deformation in concrete. So, fiber reinforced concrete can be defined as a composite materials consisting of mixes of cement, mortar, or concrete and discontinuous, discrete, uniformly disposed suitable fibers. Continuous meshes, woven fabrics, and long wires or rods are not considered to be discrete of fibers. Fibers. The fiber is a small piece of reinforcing material possessing a certain characteristics. So they can be circular or flat. The fiber is described by a conventional parameter is called aspect ratio. The aspect ratio of the fiber is ratio of the length and its diameter is known as the aspect ratio. Aspect ratio is nothing but the ratio of the length to its diameter of the fiber. The typical aspect ratio ranges from 30 to 150. The steel fiber, the typical types of fiber, steel fiber is one of the most commonly used fiber. The diameter of the steel fiber may vary from 0.25 to 0.75 mm. The steel fibers are get rusted and lost some of its strength. So the investigation shown that the rusting of fibers takes place only at the surface. So use of steel fibers makes the significant improvement in flexural impact and fatigue strength of concrete. It has been extensively used in various types of structure. Polypropylene and nylon fiber. The polypropylene and nylon fiber is increased the impact strength. So and also increased very high tensile strength, but their low modulus of elasticity and higher elongation and do not contribute to the flexural strength. Asbestos. Asbestos is also one of the fiber. So asbestos is mixed with the Portland cement. The asbestos tensile strength is varies between 560 to 980 Newton per mm square. So asbestos flexural strength the higher flexural strength than the Portland cement paste. The next is a glass fiber. Glass fiber is a very high tensile strength of 1020 to 4080 Newton per mm square. Glass fiber is originally used in conjunction with the cement was found to be affected by alkaline condition of cement. Then carbon fiber. Carbon fiber is very high tensile strength 2110 to 2815 Newton per mm square and Young's modulus. It has been reported that cement composite made with carbon fiber as reinforcement will have very high modulus of elasticity and flexural strength. Some of the factors affecting the fiber reinforced concrete. These are all, this mainly depends upon the transfer of stress between matrix of the and the fibers, which is largely dependent on the type of fiber. Fiber geometry, fiber content, orientation and distribution of the fibers, mixing and compaction of techniques of concrete, and the size and shape of the aggregate. These are all the factors affecting the properties of fiber reinforced concrete. The next volume of fiber. The volume of fiber is this diagram is shown the effect of volume of toughness and strength. It can be seen that the increase of volume of fibers increase the approximately linearly the tensile strength and the toughness of the composite. Use of higher percentage of fiber is likely to cause segregation and harshness of concrete and mortar. And aspect ratio is already we have to show the length and depth of the aspect ratio. The composite of the aspect ratio is the It has been reported that aspect ratio is 75 increase the aspect ratio increases the ultimate strength of concrete of linearly. Beyond 75, relative strength and toughness is reduced. So if it is the plain concrete, aspect ratio is 0, relative strength 1. With randomly disposed fibers, aspect ratio is 25, relative strength is 1.5. Aspect ratio is 50, relative strength 1.6. Aspect ratio is 75, relative strength 1.70. If it is the aspect ratio is 100, the relative strength will reduced. So more than 75 aspect ratio, this relative strength is reduced. Then fiber content, 0.5 to 2.5% by volume of mixed steel is 1%, glass is 1%, nylon is 1%. Then some of the application is mainly the advantages of static and dynamic tensile strength. It is mainly used for the airfield, road pavement, industrial borings, bridge decks, canal lining, explosive resistance structure, and the refractory linings. These are all some of the applications. Thank you.